Here I present our work on SceneDiffuser++, city-scale traffic simulation via a generative world model. SceneDiffuser++ is a single unified, end-to-end trained generative world model for CitySim. City-scale traffic simulation takes a large map, start and end points, and simulates everything in between, including initial scene generation, agent behavior, and traffic light state prediction. It also requires dynamic agent generation, both spawning and removal in the scenario. All of these tasks are supported by our single model, SceneDiffuser++. Here are the key highlights. Firstly, we conceptualize a novel city-scale traffic simulation task, CitySim. We identify novel challenges for trip-level simulations and propose new metrics for evaluation of CitySim task. We propose SceneDiffuser++, enabling realistic traffic simulations for agent generation, occlusion reasoning, and traffic light simulation with a unified model and objective. Finally, we show strong performance on map-augmented WOMD dataset. To simulate both agent and traffic lights, we use multi-tensor as the diffusion target. Here we have two scene tensors for agents and traffic lights, with a varying number of elements and feature dimensions. Then our denoiser first projects different scene tensors into the same latent dimension. We concatenate them into a single scene tensor, and then pass to a transformer denoiser backbone. Finally, the result scene tensor gets split and projected into the original agent and traffic light features. A major part of our work is to predict agent spawning and removal and occlusion with agent validity. Therefore, scene tensors being very sparse, a lot of entries in the scene tensor are empty. How to learn these sparse tensors with diffusion is a major challenge. In this work, we use a loss mask to ignore the invalid features entries during training. During inference, we use special clipping methods to deal with invalid entries. Please check our paper for more details. SceneDiffuser++ is able to achieve superior realism for long-term simulation, which is above 60 seconds. We tried out using different planners with SceneDiffuser++ as the world model, and we found that SceneDiffuser++ consistently achieves the best performance. Next, we show several rollout examples of SceneDiffuser++ in the long run. Note in SceneDiffuser on the left, all the agents become still because no agent exiting is permitted. While in SceneDiffuser++ on the right, we can generate very realistic agent entering and exiting behaviors. This allows us to do city sim with SceneDiffuser++, but not SceneDiffuser. We also highlight some interesting behaviors that we found with SceneDiffuser++. Note how, in this example, Agent 48 is first inserted from the parking lot and then drives smoothly to merge into moving traffic. Also note that agents on the opposite lane got inserted and removed faithfully as they come out of view. In our paper, we also analyzed different rollout and replan steps for SceneDiffuser++. We also conducted ablation studies on different clipping methods during inference time. We also show that SceneDiffuser++ achieves predicting realistic agent validity patterns, as well as generating realistic traffic light patterns. Here on the left is the ground truth transition matrix, and the right is ours. This indicates that SceneDiffuser++ achieves highly realistic traffic light transitions. Please check our paper for detailed analysis. Thank you for watching. Please check our paper for all other details.